So we started as typesetters, but we moved the last 10 or 12 years into end-to-end publishing. So we publish, we help publishers publish their stuff. We are into openness, open standards, open science, open fair data, etc. So we've worked with small and large publishers, and I hope this is not too distracting in the corner. It'll go soon. Now, very important thing, I've got a lot of slides, little brief slides to make it easier. What I've tried a new thing here. I've got a QR code on each slide. Further than that, I've uploaded this whole presentation with lots of just as a PDF file, and all those QR codes are actually links. So you don't have to take notes. I'll give you the address to download from Google Drive, and it's only about 6 megabytes. So you'll have lots and lots of links. You click on that, you go to the URL that you need to go. So I won't talk about our business much, but again, you click on that link when you get it, or you can take a photo with your phone if you like. A good client of ours is Gigabyte. They are fully open. They tick all the boxes, and we work together really to push forward the way of how we communicate research. Again, very briefly, my interest in graphics goes a long way back. When I was thinking, I thought, well, it's actually a long time back. I did my PhD in display holography. It was the first PhD in, if you like, pictorial holography. This is hologram of me as a young man, and the hologram was made by Rob Monday, who's one of the best holographers. I have to tell you this, that Rob is a good friend of mine, and he got the commission to make a hologram of the late Queen of England, and he had 1 hour with Her Majesty in Buckingham Palace. He set up everything, all the things. Her Majesty came in with her dresser and the crown and everything, and he wanted to put her at ease. She said, "Ma'am, it's don't worry about this. It's just having a passport photo taken." And she said, "I don't have a passport." So boom. So I had to tell you that one, a great story. Again, just going back, graphics, when I was doing my PhD, I heard that it was possible to do graphics with computers. The only way was to actually write a Fortran program and send it to what was called microfilm. This is microfilm, which is 35-minute film without the sprockets. You can see the date in the middle here. I'm old, so this is 1978 when I started computer graphics. And it was a long story, but anyway, no desktop publishing, etc. You got back this film the next day. I went into the dark room in a photographic enlarger. I would enlarge it, and I was the first one who had computer-generated graphics. But then, of course, you had to paste it with the text onto a paper, photocopy it, and that's the best you can do. And I just remembered I'm also forgive me if this is self-centered, I'm the first person to use LaTeX in Imperial College London, so very early days in 1983, and this was that's my thesis. And we used something called cow gum, which sounds really funny, and it was, but that was the best thing to stick it together. So that's the history. I got into graphics when interactive graphics came first. I was really excited now. So Adobe Illustrator was one of the first people to have it. And that's completed the VHS video tutorial. And here this is the very first book in the UK with computer-generated illustrations. I did all the illustrations for it. It was published in 1991 by Blackwell Science, which is now part of Wiley Blackwell. So, getting to image misconduct, is there any software? There is software. There are some software. The one I've used, I'm most familiar with, is some software called Image Twin. Again, you don't have to take notes, guys. You'd have a PDF. You can click on this code, and it'll take you to the site of relevant places. So, with Image Twin, you can upload a PDF or paste an image in, and it'll tell you that, for example, it's detected these two are overlapping. And it shows you the duplications within the image or the file you've uploaded, and it'll give you duplications with other papers or other publications. It has a database, and I'm not, as I say, I'm saying image twin because it's the only one I know, but basically they have a database of all publications, so you can go back and say find out what's this a duplication of. So you can use this, but you know it catches some things. Humans catch other things. Most of the stuff that's found is people are doing by eye. Again, now I'm just the messenger here. I'm not finding these. These are the guys who are finding. Sorry, I've just put 4 that were in front of my mind, and these are ones that I've done, or I and my colleagues have done most of the animations for. Elizabeth, Cheshire, Smut, Sholto. Again, there are many more, but these are the ones that I have done most animations for, which I will show you. Some of these people are anonymous, some of them are not, so it's up to them. So let's have a look at the categories of image misconduct. What do we see? The simplest is just duplication. So what we've got is 2 images here. Someone thought, hang on, these look a bit similar. So
Wow. That's where it originates from. Lovely. And so my grandfather kept it.
I'm hearing voice in the background. Can you mute, please? Thank you. So what we've got here is, you can see it's overlapping, and obviously it's the same image. So what we're doing, guys, is we are just doing these animations. So we look on PubPeer, and all these links will take you to PubPeer, to that page, okay?
Oh, sorry to interrupt. I can't see the slides anymore.
Can you not see the slides? Can anyone see the slides?
No, something's funny.
Something's happened.
I can't see anything.
I didn't touch anything. Let me share again. Forgive me. Thank you for. I thought.
I thought something was wrong with me. I'm glad it's someone else spoke up.
Sorry about that.
Ah, that's better. Thank you.
Can you see? Okay,
Yes.
I'm sorry. I don't know how long that was going on for, but okay. I will continue, but do jump
just
in.
about a minute.
Okay, so it wasn't too bad. You saw.
No.
Yeah, fantastic. So yeah, so this is another duplication, simple duplication, and you'll notice that it's you see the resolution's a bit low. You can't quite see if it looks like it's the same image. Probably is. Resolution is something very important that I'll come back to. Yeah. So now we've got that was simple duplication. You might have rotation. And so we've got, someone has said, hey, look, these 2 look like they are they're the same image, and if we make one negative overlap, you can see definitely those are the same. Just one more in rotation. I do have a lot of slides, so that's why I was talking so fast. I can probably relax a little bit now. So yeah, this is definitely a duplication here. Of course, then you can go and do scaling. These 2 look like they're 2 different, I don't know what these are, containers, but actually they've just been scaled, so the aspect ratio has been changed, and it's actually the same thing. So that's another one. Here's another example where clearly, now if you just look at this, you think, yeah, these are 2 different samples, but in fact, if you scale, you will see that these are exactly the same thing. Now, after duplication, we look at some where it's duplicated, but it's not just duplicated. There's some manipulation there as well. So here you can see there's definitely on the right-hand side it's duplicated, but someone's painted in new things. So this is much serious. The other ones, people can say, well, sorry, I made a mistake here, and I put the same one on, but same picture, but actually it doesn't help. So here you can see the right-hand side actually matches. Here's another one. There are quite a lot like this. These are very difficult. It would be difficult for an author to explain why this happened. But if we overlap these, you can see that most of the things are actually canceling each other out, but there are some anomalies. Clearly, these have been painted in. Okay. By the way, there's no specific journal. The highest impact factor journal, the most famous journal, and the if you like the other end, they all have these things. There's no pattern as far as I can see as to which publisher publishes more of these. Of course, a lot of these are very difficult to see. You can't expect, I feel, a peer reviewer to see these when they're reviewing. But anyway, that's just my opinion. Here you can see again, there's been obviously some manipulation there, and just one more example. There we go. Absolutely matches, except for sure you've got these blotches that have been modified. For some reason, this is not my area. Colony plates, you get a lot of these, and some people probably on the call now know more about these than I do. But maybe they're easier to do. These are supposed to be different experiments. You rotate them, and hey presto, they're exactly the same, but with some changes. You get quite creative things with scanning electron microscope images. There's sort of more 3D. So what people are doing, they're doing clearly some photoshopping work. So we overlay them, and then we take one of these. This little feature here has been sort of cleverly painted in. You can see that it absolutely matches the pattern there. And that one, and another one at the top as well. So it's quite, as I say, these animations we do just to make it simpler to see what is going on. As I say, the clever stuff is done by other guys. This is quite a nice one. It looks like a sort of cauliflower thing. You look at it and say, interesting, but if you look more closely, you find that there are duplications. So someone's taken this bit in the corner, and it's quite a sort of graceful dance, I feel, when it goes from one to the other. So it's rotated and scaled, and you can't see the joins easily, but clearly this is not, this is duplication. This one's a really cheeky. Let's see, it's not just duplication. Whoa, you see on the left. So everything matches apart from something's been obviously been cut out. Western blots are very popular. Now, the problem with Western blots, again, talking about resolution, because they're small, it's difficult to absolutely say whether they're modified or not. So this is quite high resolution. And if we overlap these, you find that they do, yeah, they're pretty matching, but there's more. If we move it a little bit down at the bottom right, you'll see that actually these match too, but these have been moved down or up a little bit. So clearly something dodgy is going on here. Another Western blot. Now you can see the resolution's lower here. You can see the pixels a bit more, but it's, once we overlay them, it's pretty, I think we can say they're the same. It's a shame these pixels are there. And just one more. Yeah, so that you see, it's getting to the point where you're not sure whether these are duplicate or not, and that's the main thing sort of message I'd like to give, if I may. Now, quite often you see these. Sorry about the subject matter, but there's someone saw that these, if you overlay them, the subject hasn't been changed. However, the carpet has been duplicated. For some reason, there's a square right in the middle there that's been copied from elsewhere. Now you think, why the heck would they do this to the carpet? That's not very important. Well, what it is, I think, what it is they're trying to remove a label. So this must have been published somewhere, and there was a label A, B, or C, and they didn't want to have a white patch. In this case, it doesn't matter much because it's just carpet. But in other cases, it's not a good thing to do because you're modifying a label. I have to admit, in my own company, one of the guys was trying to do a good job, was doing exactly that to cover up the labels. And I said, you cannot do that. This is going back 15 years ago. But I can imagine a supplier might be doing that. So you saw here in the corner, there was an anomaly just like that. And then maybe just one more. There are a lot of these. And again, it's not a good thing to do. This is science. This is not artwork. So if we overlay this and move it a little bit, you find, there we go. There's you see the top right corner. In fact, if you look at the top right of the purple figure, you can just about see that square. But clearly they've painted in that thing in the corner. That is not a good thing to do. And this one is some sort of archaeology. You overlap these and you look at that and hey, something's going on. Everything matches apart from the bottom right. And I'm guessing there was a big label here and they thought, this doesn't look nice, let's patch that in. So that's what I call corner labels. And this is just one more. This is unusual, but you can see that there's a sort of blur around. Again, this is something to do with that, the label that's being put in. There are other things, I call this lab photos, for want of a better word. Now you see that on the left, these are different sizes. They look similar, but the left one has 3 bubbles. When you overlap, you find, oh, that's the only difference. They're exactly the same. Even all the scratches match, but you've got 3 bubbles in the middle. Clearly, these have been painted in. So not easy to explain that one. And so this one, again, you've got these 2 bottles, which look like they're different sizes, but in fact, it's just been stretched. And you can see it's exactly the same picture. There are a lot of what I call animals, mice, rats, etc. I feel a bit bad about this actually because, so this is, for example, what is it, a wound, exit wound or something. And these are control day 3, control day 7. Goodness me, they're exactly the same thing. It's been stretched, even the ruler's been stretched. And just one more sample. This one is mice. As I say, these are mice or rats who are, I believe, they are sort of given cancer or something. And look at this; it's the same mouse, but they've painted different things. And I feel bad about. I feel that, you know, if you're killing rats or torturing rats, and then you're actually cheating the results, then that's a very bad thing to do. It's like torturing the animals. Just for fun, before and after, these are supposed to be different pictures. If you overlay them, they're exactly the same photo, and down to the tiniest pixel. This is another one where I guess they've done some sort of surgery to make the lady's skin tighter. However, it's a Photoshop. So you see the hair and the chin, everything is exactly the same. And one more, in fact, the dentist down the road from me had this picture. I was a bit suspicious, looked it up on the web, and yeah, it's the same picture, but the teeth have been cleared by Photoshop, not by dentistry. Another area is background noise. Sometimes the picture is blurry, but the background noise is sharp, and people have found have matched the if you like the noise, as it were. So here we can see the noise. The noise matches. That means somehow this was copied. That's another area. This is one more. We'll just have a quick look at this. So this all matches out. You see all the noise cancels out, but you find that the noise cancels out in another place as well. So clearly that bit has been copied from somewhere else to cover up something. So that's another thing that you can see here. And just one more. This is quite a high-profile case, I think. I can't remember what it was, but you've got these are supposed to be different experiments, but the background noise is exactly the same. So clearly, these have been painted on, these lots. And this one also increased the contrast. You can actually see some splicing going on as well. This is supposed to be just plain background, grainy background, but when you when you overlap, so they cancel out, but you find another rectangle which shouldn't be there. So that's quite often you find two images where there's a tiny bit in the corner that they match, and you can see that that definitely leads to a matching. And the reason I show this is I thought, I wonder how many of these, the author basically, if he'd gone up a couple of millimeters, we wouldn't have known. So if this is being, you know, you've got cheated images, if you like, how many more are there that the author did their job properly and made sure that they didn't overlap? And this is one more exactly. This is supposed to be different samples. I'm guessing there's a tiny, tiny overlap in the corner. And this is actually, it's the same sample. It's being cut up. And if they'd just been a bit more careful, we wouldn't have known. There are a lot of low resolution. Look at this. We've got low resolution images. You can just about see that these overlap, but you know, you might start arguing. This is another low resolution image. This is alleged to be a duplication here. And if we overlap, we can see it's duplication. But you can see what I mean. If as the resolution goes down, and there are cases where the authors are arguing, saying, no, this is not the same image. Someone else comes along, and all these are scientists. They're doing analysis. But if only that resolution was higher, we would have known. And just a quick another one. These are alleged to be duplicated. How are you going to tell? We change the contrast, we overlap them, and they look like they look like they're overlapping, but again, open to discussion. And I don't know what to say about this. Is actually, this is about 25 years ago published. It's an old paper, but still, why do we publish this sort of almost like a pencil drawing? The vertical lines are not even straight. But even, not only is it low resolution, clearly it's a duplication that shouldn't be there. Again, guys, don't take notes. You can just, I'll give you the PDF link. You can just click on that and you'll go to the PubPeer page. On the other side of the scale, we've got high resolution images. Now, perversely, authors who have, or papers that have high resolution images, they are easier to catch. So if, in a sense, let's have a look at this. So if you zoom in here, you can actually see the round stamp marks or pen marks that have been used to duplicate this image. So it's a bit sort of perverse, isn't it? So if you don't want to get caught, make sure you don't have high resolution images. So it's a little bit of a dichotomy there. This is another high-res image. We have a look at this. We find that, these are exactly the same, but you've got some bubbles here, which are actually, so these have been modified. If you see this bubble in the middle, when we overlay the other image, it's on the side. Another category, quite popular for cheating, I guess, is X-ray diffraction spectra. There are absolutely thousands of these, and so many of them with like 5 spectra, all exactly the same. Some areas are, if you like, good at doing these things, some countries, and others, you can see there's exactly the same. So complete copy. Then sometimes you get with the vertical scaling. So we'll copy that. It's a bit more difficult to see, but actually it's exactly the same. You come here, you scale it a little bit. There we go. And the top one is exactly the same. I'll jump to the next one because another one quite a lot is there's so many of these. I just, you know, you get tired of them. These are horizontal replications. You've got noise that's been copied and pasted. So this goes on, and it's so obvious that this, you would expect anyone to see this, to be honest with you. And this is one where it looks like these are different. These are not the same, you can see. And however, when you actually go and when you overlay and you zoom into the right-hand side, you find that this wasn't long enough. So the authors added some noise, and these three are exactly the same noise. The right-hand side is exactly the same. And then the next thing is X-ray diffraction spectra with manipulation. So here we've got, these look more or less, if you look at these, the spectra look the same, but they've actually been very they've been modified. So you can see here that's more or less matches. However, now if you move it up a little bit, you'll find that the other part matches. There we go, you see. And it's the same with the next one as well, so I'll jump. Okay, some Photoshop tools. We've got the clone stamp tool has been around for a long time. So we've got basically you click on the eye and you say I want to draw this, and you paint, and you can see you can change the brush size or the blurring of the brush. So that's been around a while, and you can see that's obviously that could be used for you know, for if you like copying and filling in things. Slightly more sophisticated is something called a content aware fill in Photoshop. I used to use Photoshop. I haven't used it for a long time, so I'm not an expert. But basically, sorry, I'll go back to here. So basically, you go around this coffee cup, you select it, and you say, take the coffee cup out, and it takes it out, does what it can. Jana is on the call. Thank you, Jana. I noticed she kindly gave me this example. By the way, Jana does a lot of really good work in Photoshop and in the series with FebsPress. So basically, on the left, you've got this anomaly, and you want to get rid of that. You don't like that black blotch, so you say, you put a circle around it. You say, get rid of this for me, and Photoshop gets rid of it. On the right is the result. And the reason yeah, so let's see what happens. If we now reverse this and overlap, we find, yeah, there is this rectangle. Now you couldn't see that rectangle. Photoshop does a good job, but the rectangle is there. And that's how it's done that. So that's the content aware. And I came across that because there's several cases I came across where a big part in the middle of an image, and it was clearly that wouldn't have been a label, but I'm guessing there was an anomaly, and someone said, look, make this look better for me. Scientific publishing. Right, this is the most frightening thing, guys. I don't have an answer to it, and I don't know what we're going to do. I haven't used it, and it's new. It's called generative AI in Photoshop. So you take an image, and you say, you put it in Photoshop, and you write classic car from the 50s. Put in a classic car from the 50s. It puts a classic car from the 50s with the right lighting, with the right shadow. You say, give me a reflection pool filled with blue. It gives you that, and it puts a reflection of the car that it put in. You say, give me some cloud, it gives you some cloud. And then you say, this is not wide enough. Can you make it landscape for me? Makes it landscape. So I don't have an answer to this, but this is coming. What are we going to do about this? I came across something, Professor Horbinsky, who kindly allowed me to show this here. This is where he took, on the left is the original image, and he said, hey, Photoshop, get rid of this thing for me in the middle, and it got rid of it. And what we have is, so, you there is no, how are you going to tell? If the original wasn't there, I don't know how we're going to tell. This is another one. Change these, whatever this cell is, to another shape, and we've got, that's the difference. So where do we go? What's the answer? How do we solve this? Let's look at file sizes, and I'll say why. A typical file size, say you take a selfie or the kids take selfies, is roughly of the order of 2 megabytes. A 1-minute video on your cell phone is of the order of 10 or 20 megabytes. Obviously, it depends on resolution and on compression. When you send it, it reduces the file size. 1-minute animation is around 40 megabytes. So that's the animations that we're doing, for example. My presentation I showed you today, obviously there's a lot of videos in there and I'm not showing all of them. However, it's 2.6 gigabytes, right? So these are the file sizes. The file size of an average PDF that you download is around 2-3 megabytes. Okay. So I may be missing something here, but I'm feeling that why is our article PDF not bigger? And why aren't the images more higher resolution? Just a quick note about compression. So there's lossless compression, which doesn't throw any information away. But if you want high compression, you use lossy compression, and JPEG is the most common one. On the left, we have an image, one you saw previously, I think, 600. That's 600K. You JPEG compress it 45K. JPEG is designed to fool the eye, and it moves pixels around. It knows that the eye can't tell. It's basically so that it's good for a photograph. But I feel we've got to be careful when we use it for scientific images. So here you can't see much difference. The two are the same. But when you zoom in, you find that you've got these artifacts. So this is the original, and on the right you find these typical sort of rectangles. It makes a square, and within the square it does a sort of algorithm, and the file size gets much smaller. And one of the files I showed you before, it's actually around 20K. It could even be smaller if it was properly saved. So I just feel we've got the resolution. We should have much higher resolution in our publications. Quick note about vector files. Again, I won't go into details because of time, but basically bitmaps, what we've seen so far is bitmaps, pixels on the screen. A vector file is, this is quite a lot of XRD spectra are in vector form actually. A vector file has no pixels. So if you zoom into this, you'll find that it's still smooth. If you keep zooming in, it's still smooth. And this is what Adobe Illustrator more or less invented. There are no pixels. So that's a good way. If you have that kind of diagram, like lines, it's best to have vector. Finally, I'm going to say there are things we can do, but the elephant in the room for me is image file sizes. So I really want to discuss it with you guys, but use vector files where possible. Publish vector, because then you haven't got the pixels. Of course, if it's lines, if it's the original is vector. Let's demand and publish higher resolution images. Minimize JPEG compression as far as we can, because we don't want to push pixels around. Why are we not publishing PDFs which are, say, 50 megabytes as opposed to, say, 3 megabytes? But we can have, if someone's got if you've got a problem, we can downsample that automatically, very easily, to 3 megabytes, so still that lower version is available. In any case, even if we are doing the 3 megabyte file, let's put the original, say to the authors, look guys, if you've got whatever images you have, put the highest version you have with no compression, dump it into here as supplementary data. You don't have to label it, what have you, so it's not extra work, right? And you've got nothing to hide. Just put it in there so that when the sleuths come along, or people like me come along, we can go in there and say, right, let's get the higher resolution. At the moment, as far as I can see, the definitive version is in the PDFs. That's it. That's the highest you can get. That's the end of my presentation. And I don't know if Jenny can speak, or I don't know where to go from here. I can, thank you. Okay. Do you have voice, Jenny, or what shall I do? Okay. She has no microphone. If you'd like to ask a question, please raise your hand. Yeah. If there are no hands, I'm going to be I'm going to be depressed today.
Yes, Kaveh, can you hear me?
I can.
Okay, very good. Thank you very much for the presentation. I was wondering, do you really think that the high resolution will fix the generative AI problem, or?
I honestly don't know. I'm guessing it'll help. I don't know much about the generative AI. I'm really afraid of it. But at least for the problems that we have now, when people are copying, etc., let's get rid of any debate as to whether this is the same, a Western blot or not. Please speak up, anyone. We've got Sean.
Morning, Kaveh. I'm just wondering about the PMC guidelines and high resolution images, because PubMed Central technical guidelines for journal inclusion actually require high definition or high resolution images, like at least 300 DPI TIFF. So how is it that journals are kind of getting away with putting out really low resolution images when, in order to be included in PMC, you need to have high resolution images?
Okay, thank you for that. The image that the really low resolution image that I showed you, that's 20K, but actually the pixels that are there, that could be 2K, literally 2K or 3K. You could have a low resolution image, but upsample it or save it as 300 DPI. Yeah, so it's still low resolution, but it's got more pixels in it. You can fill in the pixels. Yeah, and you can still have JPEG. For example, I might have JPEG compression, but I save it as a 300 DPI TIFF, and it passes the test and it goes. So that's the problem. Does that answer the question? Sure.
Yeah, thanks.
I can't see here who else. Please speak up, because I can't see where the hands are.
Okay, I have a question. It's Monica.
Hi, Monica.
Hi, let me turn on my camera. There we go. There we go. Okay, so I keep thinking about these images that so I worked as an editorial assistant at a journal. We will not say which journal it was, but on my first day, my job was to prepare to ensure that manuscripts were complete enough to go to peer review. And the first thing I noticed was that even though p-values were reported, there were no descriptive statistics, there was no data, there was nothing. It was just the p-value that was reported, which of course is tremendously problematic for many, many reasons. My impression from these images is that that's pretty much what's happening here. We're just reporting the image, but there's no provenance information. So I'm wondering, and if I'm completely out in left field, that's totally fine. I'm comfortable being wrong, but I'm wondering if one way to address the problem, not the only way, is to establish provenance documentation. How were the images generated? What are the time steps? What code was used to prepare them? I mean, how exactly were these images prepared? And no two images are prepared exactly the same way. I mean, we do that with, and we would not, in good science, we would not dream of simply reporting p-values. And from my experience with this journal that also reported Western blots and other kinds of things, they didn't have p-values. What they had were these images. That was their evidence. So why are we accepting these images as evidence alone without provenance? Okay, I'm done.
Yeah, I agree. I don't have a good answer. It would be, you need provenance. We don't know which image software they used. We don't know. I mean, what you want is the image to come out. If the image is coming out of a SEM, you want the provenance from that. It came from here. That was a format it came, etc. So you can go back. I don't know at the moment. We just ask for a picture, and as I said to Sean's question, if it's a 50 DPI, I can upscale it to 300 DPI, and no one's going to complain, as as we can see. Yeah. Can I just, there's a couple of chats. Now I realize that your company is responsible for all the animations. I've been seeing on PubPeer. I recognize some of my own observations in your presentation. I see on YouTube channel, there are 1,000 animations. Correct, we've done about 1,500. Thank you for doing these. How did you get started making these animations and why? Just out of interest, I love graphics. And I haven't done all of them. My colleagues helped me. And it was just right. I started doing them because I saw what in the early days what Elizabeth Bick was doing, and I really couldn't see. She's got magic eyes. I really wanted to make sure these are the same. That's what I wanted to do. It's just for myself. And when I did it, I just got hooked on doing those. And there are the reason I'm doing that. There are things that, for example, you saw that orange boxes where some things have been photoshopped. It makes it easy to see those. And sometimes you can see things that you wouldn't see otherwise. For example, if the author says, "Oh, I'm sorry, I put the same figure twice." Well, how come this was blotted out of here? So it helps from that point of view. And if I can just, a question from Jenny, we've known about issues with Western blots and cell images for a long time. In your opinion, what are the image problems that are flying under the radar at the moment? Can we raise awareness of those other types of image problems? I don't have okay. As I say, the easiest thing, elephant in the room, is please let's have higher resolution. Our kids are sending selfies, our kids are sending videos at 10 megabytes, and we've got images that are 20K. And this is like a year's work of someone, in the lab. So that's the one thing I can say there. But I can come back to that. If I go to the next one, totally agree with Monica's point of view on provenance. This is from AEB. Hang on. I think we need more paper trails for images and data. These are hard to fake, easy to generate prospectively if you are doing the right thing. Yeah, I mean, this is the basis of open science, open data, open science, fair data. Fully agree with that. There can also be an issue with journals or publishers enforcing image and many other manuscript requirements. You see, I've been here a long time in the business, and even from the early days, for 20 years now or more, it's been the same thing. As far as I can see, it's 300 DPI, and then if it's line art, it's 600 DPI. Now, there are other things. It depends on the total number of pixels. If it's a small image with 300 DPI, it's going to be it'll have much more resolution. I think we should just ask for the biggest file. If it's 500 megabytes, that's fine. Just dump it in here, and so that it's there, and we'll deal with it. Yeah, I don't. the DPI, remember, DPI is dots per inch, and it goes back to the print days, and that's why we measure in DPI. It's actually the total, it's not related to the total number of pixels. So we should really think about it in a different way. And the easiest way to say, look, give us the biggest file you've got. It doesn't matter how big it is. Do some journals do some journals use numeric tools to explore duplication or possible problems in pictures? I think you can use things like image twin that I mentioned, but yeah, it's this idea of using these tools is new, that you can actually go in right at the beginning and say, is there duplication? That's all I can say. But it's still, we're getting more and more. We're not getting less duplication. We're getting more. How do you decide to try to overlap two images? All I'm doing is looking at what's report. I go into PubPeer and I look at. By the way, please go to PubPeer, and there are very good search options in PubPeer. So you can say, for example, find name of someone and minus fig star, so it doesn't have any figures, etc. So you can home in on what you want. So I go and say find figure and then minus my name that's in there. By the way, let me just, before I forget, this is the right. So this. So this is a PDF file. It's about 6 megabytes. So it's all my presentations, and all the little QR codes are links. Tell me what you think. If it works, that it's a good way, so you don't have to take so much notes. God, where was I? Yeah. So I look at PubPeer. I go in there and I search and I look at the latest one. I look at something that's in, pure overlap is just a bit boring now. But something that's challenging, I look for because that's something that overlap shows. So I only use the overlap when I know there is someone has said there is an overlap. So I'm not doing it just willy-nilly. Right. Right. This is the big question. I'm nervous already, but perhaps an important one. Should PDFs be a standard for scientific figures and images? Would it be beneficial to shift towards uploading raw images as supplemental material? Very good question. Okay. PDF, a lot of people say, oh, let's forget PDF. No, I love PDF, and PDF is here to stay. PDF but first of all, I don't think PDF should be if you like, what I've called the format of record. I give presentations where I say XML or some structured data should be your format of record. That's the content. You press the button and you create a PDF. We go from XML to PDF fully automatically. So it should be one output. You might want EPUB, you might want, if you have a disability, if you're visually impaired, you might want text to voice. So that's what you do. So PDF should be at the end of the process. You should upload high resolution images. From those images and the XML text, you can create a PDF, and you might say, I want the PDF that's lower resolution or lower because I don't want a big file size. So it shouldn't be the definitive thing ever, I believe. Right. You can share this with colleagues. So as far as I'm concerned, that PDF is open, and you can. I don't have a problem with it. Sorry, please speak. I just saw Thomas Stoger hand up.
Thanks, yeah, but it might be the second in line. Thanks for your talk. It was really nice. I was curious of a question. Whether actually low resolutions and compressions would actually be something we could use as our advantage. Specifically, I'm thinking about also generative AI probably being about the image that is displayed to the user, whereas the images are also represented in frequency space. And I've seen things, in particular with chest X-ray, where images look the same to humans, but basically algorithms can pick up that there has been like some sort of compression going on. And if like so, you could so basically, if like there's like an additional layer in there, like looking at how things get downsampled, and also having a different level of detail being generated by generative AI that is not matching the level of detail that the image would usually have.
Okay, the sound was a bit bad. I didn't catch all of that. But what you're saying is that, again, it's a bit like the question of provenance. So you have a high resolution, and from that you can go to a low resolution. Is that right?
Or if like some intermediate level of resolution might even be better. So one is like us looking at images, but another way of representing images is like in some kind of mathematically transformed space. For instance, Fourier transformation or discrete cosine transformation, basically something similar to what actually JPEG uses to cut most information and then regenerate the information. And this thing is like, it's another representation of the image that is not so easily accessible. But basically, whether that type of space of looking at the image in frequencies actually has differences with generative approaches and real images, where the level of detail would depend on the overall resolution of input images. Like where there would be like probably some level that gets. So like basically if there's like a certain discrepancy, and I'm not sure at which level generative approaches typically work with Photoshop and commercial ones, but I would expect them to target one level that is not necessarily the same one that microscopy images or scientific applications use.
Okay. I didn't quite. I think it's above my pay scale. That so I think I'd love to talk to you about that again. Jana, I don't know if you were. Do you want to? No. Okay. So that was a bit difficult for me. But while you were talking, I thought that maybe we can have some sort of encoding of the figure, so that if someone cheats, a bit like a sort of hack. Sorry. Jana.
Yeah, I just wanted to say that I'm not sure. So I don't have such a huge problem with resolution when can you hear me?
Yeah.
Yeah, okay, sorry. So I don't have such a huge problem with resolution normally. Okay, so I do a lot of pre-publication screening, so of course I have access to the to the figure files as they're submitted to the journal. But also with published work, a lot of journals have this figure viewer now, and if you enlarge the figure and then you take a screenshot and then you use that part of the figure, it seems to help quite a lot. So I'm not sure that the problem, I'm not sure how to say this. So I think that really the problem that we have with undetected image manipulation and duplications, I'm not sure that it's the resolution that is really the main problem.
Okay.
I think it's partly that we don't have enough trained staff, and not enough journals are actually employing people that do this kind of work. They're not, it's not rewarded in the way that it should be. Journals aren't reacting in the way that they should be reacting. I think those things are really what we need to look at. I mean, yes, if you're looking at a paper that's 8 years old, then, or 10 years old or 15 years old, then you are bound to find, to have figures with low resolution. But I don't really think that's the core of the problem, and it's not really the path to the great remedy.
Okay, no, there are a lot. I agree with everything you said, but at the very least, what I'm thinking, even if it's not duplication, misconduct, let's have the higher resolution for science. because if you have a photograph of cell structure, etc., you don't want to downsample that. Let's have the highest resolution so that because there's more information in there. And let's try not to use compression unless we really, really have to. And for specific things, if image of a field, it's no problem if you have if you have JPEG compression, but you don't want it in this biological material.
Then I think you're completely right about JPEGs. They should just be outruled. I mean, I always say that journals shouldn't accept JPEGs altogether because of compression. It doesn't help. It's completely right. I agree with you.
I'd just like to thank you also for all the work you've done, Jana. Very excellent work. Thank you. Right. We're okay. I'm Jenny's mouthpiece here. We're nearly the hour, so we should wind up. Thank you, and thank you, Jenny. Yeah, fantastic. Well, thank you very much, guys. On that PDF, my email is on there. Everything is on there. If you want to get in touch with me, I'd love to talk more about this. It's the first time I've actually presented this, so I really, am I missing something? I'd love to talk to you, and Thomas, I'd love to talk to you as well about the other stuff. Thank you so much.